Okay. Good afternoon, all of you. Uh, Today's topic is your stopping side distance. Already we have seen the stopping side distance, the formula of stopping side distance or simply side distance. Normally, the stopping side distance is uh, divisions of the lag distance and the braking distance. So braking distance and summation of braking distance and lag distance, we can say the stopping distance. Now initially, if we talk about the stopping distance, so there is a problem or numerical which is need to be solved. So first problem, uh, I have taken from the Khannajastu book. Already the book which is given to you as a e-copy. You can see in your e-copy, or if you have the Khannajastu book, you can follow the book also. The example number 4.2 and the page number, I think 92, page number 92, you can see this problem. And the solving of this problem, as well as how can we solve this problem, it is important. The problem is very important to solve and very interesting also. The problem is to calculate the safe stopping side distance for design speed of 50 km per hour for condition 1, two-way traffic on a two-lane road. Okay, two-way traffic on a two-lane road. That means two-way traffic with divider. The divider is present in the road or on the road. Divider is present and traffic is two-way. And number two, two-way traffic on a single plane road. That means no divider is there, but traffic is present and traffic is going in a two-way. In two-way direction, traffic is available. So the condition is different. Now you have to calculate the safe stopping side distance, and the design speed is specified for the road is 50 km per hour. Now the solution. Now we will go to the direct solution. Design speed is 50 km per hour, and the condition is, first condition, two-way traffic on a two-lane road. Second condition is two-way traffic on a single plane road. Let's see. In the solution part, now you can see it is written that assume coefficient of friction as 0.37 and reaction time of driver as 2.5 seconds. Okay. Okay, this is also mentioned in the question. Even you can assume, as already I think you have the idea about the coefficient of friction value and the reaction time value. So you can assume if it is not mentioned in your question, in your given question, so you can assume. But in this question it is given, that is assume coefficient of friction as 0.37 and reaction time of driver as 2.5 seconds. Now direct we will go to the solution. Stopping distance. What is the formula of stopping distance? Already we have seen in the last class. The formula of the stopping distance is Vt plus V square by 2gf, where Vt is the lag distance and V square by 2gf is the braking distance. Okay, so same as stopping distance is the lag distance plus braking distance, and formula is Vt plus V square by 2gf. Now our design speed is 50 km per hour. So when we will use this formula Vt plus V square by 2gf, we have to convert kilometer per hour to meter per second, because this formula is applicable when the unit is meter per second. Okay, and if you want to use this kilometer per hour directly in the formula, then we have to use this formula. 0.278 Vt plus V square by 254 F. Okay, but if we want to use this formula Vt plus V square by 2gf, then we have if it is given in kilometer per hour design speed, then we have to convert into meter per second. So 50 kilometer per hour is the 50 by 3.6. So easily we can convert it into 13.9 meter per second. Okay. T is already mentioned in the question, that is 2.5 second. T is the reaction time of the driver, 2.5 second. G is 9.8. F is also mentioned in the question, that is 0.37. Now calculate the stopping distance, safe stopping distance. Formula is Vt plus V square by 2gf. V after conversion 50 km per hour, V is our 13.9. 13.9. T is 2 into 2.5 plus again V is 13.9 square by 2 into 9.8 into F is 0.37. So this is the safe or stopping distance, 61.4 meter. But the condition is, first condition as per question, that is condition A, the two-way traffic on a two-lane road, and condition B is two-way traffic on a single plane road. Okay, now let's see when the alternatively we can calculate the same thing. If we don't want to convert, then we can directly use this formula 0.278 Vt plus V square by 254 by F. Same result will come, 61.4. Now the condition A, stopping side distance when there are two lanes. That means the simple stopping distance, because stopping side distance when there are two lanes, that means divider is present. When divider is present, the distance of stopping distance is very less. Distance is required for stopping the vehicle. That's why what is we are getting from this calculation, the stopping distance, that is safe distance for the first condition. The first condition is stopping distance when there are two lanes. Okay, that is 61.4 meter. Second condition, condition B, when the stopping side distance for two-way traffic with single lane road. Okay, single lane road, that means there is no divider is present in the road, on the road, and for that case we have required the maximum distance, maximum space for stopping our vehicle, and for that case this safe distance or this stopping distance will be twice of the stopping distance. Whatever we are getting from the calculation, this value will be 2 times. So also you can see in the solution section that for B case, stopping side distance for two-way traffic with single lane, that is equals to 2 into stopping distance. 2 into our result was 61.4. So 2 into 61.4, that is 122.8 meter. So our result would be for single lane road, stopping side distance for single lane road is 122.8. And both the cases, both the road cases, single lane road and double lane case, traffic is in two-way condition. So easily, if you can remember this formula Vt plus V square by 2gf, you can calculate the stopping distance. Okay. Next problem. There are a number of problems, different kind of problem, different aspects are mentioned. Now let's see the second problem. Second problem is calculate the minimum side distance required to avoid a head-on collision of two cars approaching from the opposite directions at 90 and 60 km per hour. Again I am repeating, the calculate the minimum side distance required to avoid a head-on collision of two cars approaching from the opposite directions at 90 and 60 km per hour. Assume a reaction time of 2.5 seconds, coefficient of friction of 0.7 and a brake efficiency of 50% in either case. Either case means both the cases. That means the calculate the minimum side distance required to avoid head-on collision to overcome the accident, that means head-on collision of two cars approaching from the opposite directions at 90. The speed of one car is 90 and another car is 60 km per hour. Both are opposite to each other. Assume a reaction time of 2.5 seconds. This is the very common 2.5 seconds. Everywhere you can see the reaction time of the driver is 2.5 seconds, because already we have studied the PEEP theory and all the things which are related to reaction time of the driver. So as a conclusion, we can see the reaction time always would be the 2.5 seconds, and coefficient of friction of 0.7 and a brake efficiency of 50%. Okay, this is the new thing which is introduced in this question. The brake efficiency of 50% in either cases. Either cases means both the cases, for both the vehicles, and the vehicles are on the same road. So these conditions are applicable for the same road for the both the vehicles. Just difference is the speed of the vehicle. One vehicle is going with 90 km per hour and other vehicle is moving with 60 km per hour, and both are opposite to each other. Now let's see the solution. Same stopping side distance or safe side distance formula is same, Vt plus V square by 2Gf. Now V is different for different cars. So first one, V suffix 1, that is 90 km per hour. Now let's convert to the meter per second, that is 25 meter per second. V1 is 25 meter per second, or 90 km per hour. If we convert 90 km per hour, then it will come 25 meter per second. Next V2 is the 60 km per hour. Okay, now let's convert this 60 km per hour. The value is 16.67 meter per second. Okay, as now this is the important, listen, as the brake efficiency is 50%, the wheels will skid through 50% of the brake distance and rotate through a remaining distance. Okay, so the efficiency of the brake is 50%. Therefore the normally we have seen that the efficiency of brake, always we are considered efficiency of brake is 100%. Even in the earlier question you can see the coefficient of friction is 0.37. That means the efficiency of the brake is 100%. When efficiency of the brake is 100%, then it is 0.37. But in that case the efficiency of brake is 50%. That's why now let's see. Therefore the value of the coefficient of friction developed, F may be taken as 50% of the coefficient of friction. That is F should be 50%. Okay, because efficiency of brake is 50%. This friction normally is generated due to friction between tire and the surface of the road. So when the friction is generated from the tire and the surface of the road, and the efficiency is 50%, that's why already in question it is mentioned that the coefficient of friction is 0.7, and it is with efficiency of 50%. That's why we have to consider 50% of this 50% coefficient of friction. Okay, so F should be F equals to 0.5 into 0.7. Clear? Now calculate the stopping side distance for the first car, SD suffix 1. The velocity was 25 meter per second. We had converted from 90 km per hour. So 25 into reaction time 2.5. This is Vt, V into T, plus V is 25 square, V square by 2Gf. 2 into G is 9.8. F is 50% we have taken. So 50% of 0.7 is 0.35. Now the SD1 is 153.6 meter. For second car, HD suffix 2, HD2. For second car, we had converted 60 km per hour to 16.67 meter per second velocity. So velocity is 16.67 and the reaction time is 2.5. 16.67 square v square by 2gf. 2 into g is 9.8. f is 50%, that is 0.35. So hd2 is 82.2 meter. Now question was calculate the minimum side distance required to avoid head-on collision of two cars. Okay, so minimum side distance to avoid head-on collision. So side distance to avoid head-on collision of the two approaching cars would be HD1 plus HD2. HD1 value is coming 153.6 and HD2 value is coming is 82.2. So side distance would be summation of HD1 plus HD2 to avoid head-on collision of two approaching cars. The value is 235.8 meter. This is the answer. Okay. So I think the side distance, the idea of side distance is clearing to you, because first problem you have seen that the one velocity of a single vehicle was given, and from this velocity we have calculated the side distance. Just the difference was in road condition. The one road condition was the stopping side distance when there are two lanes, and another road condition was stopping side distance for two-way traffic with single lane. But in the next problem we have seen same road condition is same, all the conditions are also same, like your braking efficiency, coefficient of friction. Just one condition was there, that is the efficiency of brake was 50%, and two vehicles are coming to each other and in the opposite direction, both are in the opposite direction to each other, and the speed was 90 km and 60 km, and we had calculated the side distance to avoid head-on collision of the two approaching cars. Okay, now the third problem, we are going to towards the third problem. What is the third problem? Third problem is calculating the stopping side distance on a highway at a descending gradient of 2% for a design speed of 80 km per hour. Assume other data as per IRC recommendations. Okay, now in the question it is talking about the gradient. Okay, these are all about the plain road. Okay, plain road. These conditions are applicable for plain road. We had no idea about the gradient of the road, or what would be the braking efficiency, what is the condition will be for the gradient, maybe ascending gradient, maybe for descending gradient. So we have no idea about gradient. Now let's go to the gradient condition. So there is a different theory when the gradient is present in the road, or gradient sections are introduced in the road. Let's see, we have idea lag distance, braking distance to calculate the stopping side distance. Now a theory is mentioned for the gradient, or we can say stopping distance at slopes. Stopping distance at slopes. When there is an ascending gradient or ascending gradient, okay, positive gradient, up gradient. When there is ascending gradient of say positive n% or plus n%, the component of gravity adds to the braking action and hence the braking distance is decreased. Obviously, when car will go through the ascending gradient or up gradient, the distance traveled due to the application of brake will be decreased. This is the natural thinking or natural phenomena due to our gravity. So how can we calculate or how can we consider that actual distance or braking distance which will be considered in this ascending gradient? Let's see the component of gravity acting parallel to the surface which adds to the braking force is equal to W sin alpha, and this alpha value is very less because the gradient of the road is normally very less. That's why we can also take as W tan alpha. Okay, so W is the weight of the vehicle and alpha is the gradient angle of the gradient, and tan normally this is the height to the, this is the ratio between height to the hypotenuse, and normally this is your slope. N is slope, so n by 100, n because n in percentage, so n by 100. Simply we can multiply the weight of the vehicle with n by 100. N is the slope. Now equating kinetic energy and work done, this is the theory portion. This will not come to proof, but for understanding we will go through this. So Fw plus Wn by 100 equals to, this is the kinetic energy, half into Wv square by g or Wv square by 2g. Okay, so Fw plus Wn by 100 into L equals to this. So L is V square by 2g into F plus N by 100. Okay, assume, sorry, next page is this. Similarly in descending gradient of negative n%, okay, or minus n%, the braking distance increase as component of gravity. Acha, in descending gradient the braking distance will increase. In ascending gradient braking distance will decrease. In descending gradient or down gradient the braking distance will increase. Okay, because the car is going in down direction, there if we apply the brake, the properly brake will apply after a more distance, after traveling the more distance of the car. So in the descending gradient or down gradient braking distance will be increased as a component of gravity now opposes the braking force. Hence the equation is Fw, it should be minus, it is written wrong, so Fw minus Wn by 100, okay, into L, same Wv square by 2g. This is the kinetic energy, so L is V square by 2g, F minus N by 100. Okay, this will be minus, negative, wrongly positive is wrong, this is not correct, printing mistake. So hence the general equation for stopping distance may now be modified for n% gradient. Maybe your gradient is ascending or maybe your gradient is descending. Both the cases, this is the common formula for slope, the side distance to calculate the side distance, that is Vt plus V square by 2g A plus or minus, depends on condition. So A plus or minus 0.01 n. N is the slope, okay, which is only you can get from the question. If in your question it is mentioned that is gradient is present, also it should be mentioned the ascending or descending, or maybe ascending gradient. One question may come come for ascending, and one question may come for your descending gradient. Both the value of the slope should be mentioned in the question. So n value will be available from the question, V also be available from the question, T reaction time is always normally 2.5, G is 9.8. Now let's see the actual problem which is asked in the numerical. Also something is written here, equation be written as follows, where V in kilometer per hour and the gradient is n percent. So if we don't convert, if the velocity of the vehicle is given in kilometer per hour, if you don't want to convert into meter per second, then directly we can use this formula, 0.278 Vt plus V square by 254 A plus or minus 0.01 into n. So this formula can be used. As the stopping side distance SSD required on descending gradient is higher, it is necessary to determine the critical value of SSD for descending gradient on the roads with gradients and two-way traffic flow. The minimum stopping side distance hence should be equal to the stopping side distance one-way traffic. So this theory already we have already solved problem. I have said verbally, I have said all these things. Now let's see the actual problem of slope. Okay, the stopping side distance, calculation of stopping side distance in slope. Calculating the stopping side distance on a highway at a descending gradient of 2% for a design speed of 80 km per hour. Assume other data as per IRC recommendations. Okay, so we have to be calculate the stopping side distance on a highway descending gradient of 2%. Descending gradient means negative. Okay, descending means negative. So total reaction time T may be taken as 2.5. This is the universal value, 2.5 seconds, and design coefficient of friction as AF is 0.35. Okay, now velocity of the vehicle is 80 km per hour. N is minus 2% because already I have said the descending gradient, so this value should be negative 2%. 2% means minus 0.02 because 2 by 100, that is minus 0.02. G is 9.8 meter per second square. Now convert this V. Also we can use directly. If we use this formula, we can use directly, but in this solution it is converted. So V is 80 by 3.6, so 22.2 meter per second. Now SSD on road with gradient, safe stopping side distance on road with gradient, that is Vt plus V square by 2G F plus or minus n%. This is the formula in slope. So V is 22.2, wrongly written, 22.2 into T is 2.5 plus V again 2.2 square by 2 into 9.8, AF is 0.35 minus, because descending gradient, so we will take minus this value 0.02. Now the result is 131.7 meter. This is the safe side distance in slope. Okay, alternatively, if we use this directly, we can use 80 when then no conversion is required of the speed of the vehicle, so we can use directly this formula. But this is the actual fundamental to solve. How can we solve this type of problems? So this SSD value is 131.7. So basically you need to keep in your mind that there is a formula. Okay, the formula is Vt plus V square by 2Gf when normal condition. But when slope or ascending or descending gradient is introduced, then you have to use this formula Vt plus V square 2G A plus or minus n%. N is the slope or gradient. Okay, simple. Okay, another numerical is there. Calculate the values of headlight sight distance, number 1, and number 2, intermediate sight distance for a highway with design speed of 65 km/h. So headlight sight distance, intermediate sight. Already I had given you one. I have said that there are two types of sight distance which are normally not considered. Basically, the stopping sight distance, overtaking sight distance, these are common things. But headlight sight distance, intermediate sight distance, also these things are mentioned by IRC. Okay, but in practical, this headlight sight distance, intermediate sight distance is not very common, but mentioned by IRC in their code. But in general, when we design road or when we practice these side distance kind of things in our road design, the criteria which are very important in practically, we don't consider this headlight side distance, intermediate side distance. However, the IRC, they have mentioned their code, the headlight side distance is there, intermediate side distance is there. Okay, let's see how, if the question might be asked in the exams, so how can we solve? So we have to calculate the headlight side distance and intermediate side distance for a highway with design speed of 65 km/h. So solution, V is the 65 km/h. F, coefficient of friction, is it is taken as 0.36. You can take 0.35, no problem. T is 2.5 seconds, the reaction time of the driver. Now the side distance is 0.278. Directly they have taken the 65 kilometers, so that's why they are using this formula, 0.278 Vt plus P square by 254 F. We can use, instead of this formula, Vt plus V square by 2Gf. Then you have to convert this 65 km/h to 60 in meter per second. Okay, now after calculating this side distance, 0.278 into 65, 2.5 plus 65 square, 254 into 0.36, the value is 91.4 meter. This is the headlight side distance, same. Okay, the stopping side distance is same as headlight side distance. This is nothing is different in this calculation in stopping side distance and headlight side distance. Now intermediate side distance. Intermediate side distance is 2 into stopping side distance. Okay, so our stopping side distance or headlight side distance, that is 91.4 meter. So intermediate side distance is twice this headlight side distance or stopping side distance, 91.4. 2 into 91.4 is 182.8 meter. So basically stopping side distance, if you can calculate the stopping side distance, you can calculate everything. Just you need to practice or some parameters you have to keep in your mind, because there is you have seen there are lots of things like head-on collision things, so road condition, single load, double load, two-way traffic, okay, and the gradient, slope. So depending upon the this such type of conditions, you have to calculate the results, you have to calculate the solution. So today we have already completed this stopping side distance. Okay, now from the next class, I think from the next class we will go to the overtaking side distance. Okay, from the next class we will go to the overtaking side distance, and today I will send you the one Google quiz. Please solve and by tomorrow. Okay, Just wait, I'll take the attendance. Yes.
क्या वो मल्टीप्लाई क्यों कर देते हैं ब्रेकिंग एफिशिएंसी को पेटेंट ऑपरेशन में?
Wait. Braking distance and lag distance. Okay. Braking distance and lag distance. In earlier class, I have told you that the lag distance totally depends on your during the total reaction time, or PEEP theory. Okay, PEEP theory means the the things are related to the human being, things are related to driver, things are related to our nervous system, our spinal cord. Okay, so when we observe any obstruction on the road, normally some reactions are started. Okay, so for these reactions, some distance are already traveled by our car or our vehicle, because vehicle is the mechanical thing. We are human, normally we are operated our vehicles or our car. So when we just observe, or first instantly we see some obstruction on the road, normally some reactions are started. Okay, some reaction are taken place in our brain. That's why for this instant time, some distance are normally traveled by the our vehicle or car, and this is called the lag distance. And this distance which is traveled by our vehicle during this our reaction, this is called lag distance. And when we realize that we have to apply brake, or we have to stop our vehicle, then we apply the brake. But this application of the brake, when we apply the brake, instantly the vehicle will not stop. Okay, vehicle will stop after some time, after application of brake. And this distance, this during this time, application of brake and finally stopping of the vehicle, during this time, the distance traveled by our vehicle is called the braking distance. That's why the stopping distance is divided into two parts: lag distance and braking distance. And the summation, or in the other sense we can say, the summation of the lag distance and braking distance is the stopping side distance. Clear? Just wait, I am taking the attendance. Just wait. Thank you. You can leave. Okay.